Hi everyone. Today's problem is max circular Subarray sum. So the problem statement: given an array of integers ARR in a circular fashion, find the maximum Subarray sum that we can get if we assume the array to be circular. So in the first example, the array is 8 minus 8, 9 minus 9, 10 minus 11, 12. Since this is in a circular fashion, the minus 12 will then be connected to the 8. So, if we try to take sum of all the subarrays, then the maximum that we will be getting will be 12 plus 8, 20, minus 8, which is again 12, plus 9, 21, minus 9, which is again 12, plus 10, 22. Same way, for the next example, if you take all the numbers, then the maximum will be, in this particular case, it's 7 plus 6 plus 5 plus minus 4 plus minus 1, then again to 10. Same way for the third example as well. So we mainly have three conditions to check. First one is if all numbers are positive. If all are positive, if all are positive, then it is pretty straightforward. Suppose the array is, I'm taking a simple example. The array is 1 to 3. Then the maximum subarray sum in a circular array will be 1 plus 2 plus 3 or 3 plus 1 plus 2, anything. The total sum array will be 6. The second case is if it is negative, if all the numbers are negative, then it will be, for example, minus 1, minus 2, minus 3. And this particular case, if we take all the numbers, then it will be minus 6. But minus 6 is less than minus 3. It is less than minus 2. It is less than minus 1. And of all these numbers, the smaller number is minus 1. So in this particular case, the answer will be minus 1. So for positive and negative, it's pretty straightforward. And the issue arises when we have negative numbers. Suppose say we have one example, 1, 2, 3, say minus 1, 1, and a minus 10. So if we have this example, the total sum will be 1 plus 2, 3, 3 plus 3, 6. 6 minus 1, 5 plus 6 plus 1, 6 minus 10 is minus 4. And we have the numbers which are already greater than minus 4. So we can't say like the total sum will be the maximum. But if we consider the total, the maximum positive value or the maximum value in this array, which is 3, which will also be not the maximum because 1 plus 2, 3, 3 plus 3, 6 is the maximum if we consider this. So, uh, suppose say like we can just take one more example. Let's take a 2 here instead of 1. So the maximum subarray in this case will be this one, which will be 1 plus 2, 3, 3 plus 3, 6, 6 minus 1, 5 plus 2, 7. So, uh, so what is happening here? What if we find the maximum subarray sum in the normal array? We can just forget that it's a circular subarray. If it's the maximum subarray sum here, then it will be this one. 1 plus 2, 3, 3 plus 3, 6, 6 minus 1. 6 minus 1 is 5, 5 plus 1, 6. I'm just changing the input array as 1, 2. Let me consider this as minus 4, then again 2, then minus 10. So if we consider the maximum subarray, we are not considering like we are taking it as circular. If we say it's the maximum subarray sum, then it will be 1 plus 2, 3. 3 minus 4 is minus 1 plus 2 is this one. So 1 plus 2, 3 is the maximum subarray sum. And what if we say what is the maximum minimum subarray sum? And in that case, it will be let's take the whole sum for the moment. 1 plus 2, 3, 3 minus 4, minus 1, minus 1, 2 is 1 plus 9, minus 9, minus 9. So the total sum is minus 9. And minus 4 plus 2 is minus 2 plus 10 is minus 12. And we have the other negative numbers as minus 4 and minus 10. So out of all these, minus 12 is the maximum or the minimum subarray sum, which is this subarray is having the minimum subarray sum. And the maximum subarray that we found was either 1 plus 2, 3. So we have the maximum subarray as 3 and the minimum subarray sum as minus 4 plus 2, which is minus 2, plus minus 10, which is minus 12. Okay, and the total subarray sum is the total sum of the array is 1 plus 2, 3. 3 minus 4 is minus 1. Minus 1 plus 2 is 1, which is minus 9. Okay, so what is the maximum? So the maximum will be, if we consider this, like this will be connected, like it is a circular subarray. Now we can consider a circular subarray. Now if we consider this, we can start from 2 minus 10 and go 1, 2, 4, 1, 2, minus 4, etc. Or we can start from minus 10 and go 1, 2, minus 4, 1, etc. And if we already found the maximum subarray sum, which is 3, and we already know the minimum subarray sum, which is minus 12, and the total sum is minus 9. So if we take the maximum between these two, which is equal to 3 comma 3 comma minus 9, which was the total sum. So from the total sum, if we remove the minimum subarray sum, then we will get another maximum which might be possible. So in this case, it's max of 3 comma 3, which will still give us an answer 3. So taking this as the example, let me try to have one more example. Let's say we have 1 minus 1, 4, 10. Suppose this is our subarray, or this is our array. The total sum of this array will be 1 plus minus 1, 0, plus 4, plus 10, which is 14. So the total sum is 14, which is the minimum subarray sum. Minimum subarray sum, like we have one negative number. So the minimum subarray sum will be minus 1. What is the maximum subarray sum? It will be 1 plus minus 1, 0 plus 4, 4, it is still 14, is the maximum subarray sum. But if we consider this as the circular subarray, then the maximum will be this array. That is 4 plus 10 plus 1, which is 15, which is basically we have removed this minus 1. So this minus 1 is the minimum. So to find, so our maximum will be either the maximum subarray sum, in this particular case it's 14, or the total sum minus the minimum subarray sum that we have seen. So in this case, the minimum subarray we have seen is minus 1, and the total sum is 14. So 14 minus minus 1, which is equal to maximum of 14 or 15, which gives us an answer 15. So that's what you need to do. So the idea is we will be finding the total sum of the array. We will be finding the maximum subarray sum. We will be also finding the minimum subarray sum. And our answer will be either the maximum subarray sum or the minimum subarray deducted from the total subarray sum. So let's try to code that. So we can have an initial check for array is null or it's empty. We can just return 0. So we need, so our formula is max of maximum subarray sum minus total or sorry, not minus, total sum minus minimum subarray sum. So we already know the Bain's algorithm, which can be used to find the maximum subarray sum, and the similar can be reversed. Similar logic can be just reversed in order to find the minimum subarray sum. So we can just find those two subarray sums, the maximum and the minimum, and just try to find it using this maximum formula. So we need the total sum, which is equal to 0. We need the max subarray sum, which can be initialized to a very small value. We need a minimum subarray sum, which can be initialized to a very large value. We can have a random sum for max, which is 0. We can also have random sum for min. So those are basically the prefix sums that we will be calculating and we will be using to find the maximum subarray and the minimum subarray. Now we will just iterate through the array. We will update the total sum. We will update the random sum for max. We will update the random sum for min. Now we will apply the Kadim's algorithm. Like first, we will be finding whether we have a better result for the maximum subarray sum. So maximum subarray sum equal to math or max. So max subarray sum or the random sum. Min subarray sum will be just the reverse. Math dot min of min subarray sum, comma random sum for min. Now our maximum subarray basically, like if we have the negative numbers, suppose -1, -2, -3, then we can't find a maximum if we keep on adding up negative numbers to our result. So in any case, our running sum for max become less than 0. We can reset it back to we can just reset it back to 0. Else, okay, and same way for finding the minimum subarray, like whenever the sum becomes greater than 0, we can just set it back to 0. So if running sum for min becomes greater than 0, running sum for min is equal to 0. Now the answer will be either the max subarray sum or the minimum subarray sum that we deducted from the total sum. So the time complexity will be below length of the array. We are not making use of any extra space. So space complexity will be below here.